Hello all, welcome to Tumula online classes. Now in this session we will discuss new concept. Today's concept is refraction of light. Let us discuss refraction of light in detail. What is meant by refraction, what are laws of refractions, and what is principle of reversibility. That concept we will see in this session. Before that, we are learning ray optics. The study of light, rectilinear propagation of the light, that we are calling ray optics. In ray optics, already we have completed reflection of light. Now let us take one more property of the light, that we are calling refraction of the light. We know that when light travels in straight line path, it obeys lot of property. Among them, reflection and refraction is nothing but one of the property of the light. Let us see refraction of light. The new concept, refraction of the light. We know that when light travels from one medium to another medium, it changes its speed. It changes its speed. When ray of light, for example, travels from air to water, it changes its speed. When ray of light travels from water to glass, it changes the speed of light. What we know? When ray of light travels in different medium, it changes the speed of the light. A refraction property. Refraction means when ray of light travels from one medium to another medium, it changes its direction. It changes its direction due to changing in speed of light. That will say refraction means the phenomenon of changing in path of the light when ray of light travels from one medium to another medium, or the phenomenon of changing in speed of light when ray of light travels from one medium to another medium. That property we are calling refraction of light. Shall I define refraction of light in what way? The phenomenon of changing in speed of light, or changing the path of the light, or changing in speed of light. Can take changing in speed of light, as it travels from one medium to another medium, as it travels from one medium to another medium, this phenomena we are calling refraction of light. When ray of light travels from one medium to another medium, definitely it changes speed. Due to change in speed, it changes also direction. Let us take. Now I will take two mediums. Say one is nothing but air, second one is nothing but water. Look at me. Now I can take this is nothing but line separation between two mediums. I can take, let us take one medium is air and second medium is water. Right around this. Now in air, let us consider the speed of the light can be represented by c. In water, the speed of the light can be represented by v. What we know? When a ray of light that travels from one medium to another medium, it changes the speed of light. Due to changing in speed of light, it changes its direction. Look at me. How it is? Let us take a ray of light incident on the surface. Look at me. I can take this nothing but one ray of light incident at the surface. Right around. So let us take, I can take nothing but PA is nothing but incident ray. P is nothing but incident ray. We know that perpendicular line drawn at the point of incident, that we are calling normal. What we are calling normal? Normal means the perpendicular line drawn at the point of incident, this we are calling normal. Normal means n dash is perpendicular to separation between two medium. Now when ray of light travels from one medium to another medium, it changes its direction or changes its path. This we are calling refraction. How it get refracted? P is nothing but incident ray, then I can take this AB is nothing but refracted ray. When ray of light travels from one medium to another medium, it changes its speed. Due to changing in speed, it changes its direction. This phenomena we are calling refraction of light. Then during refraction, what happens here? During refraction, speed of the light changes because of changing in wavelength of the light. When ray of light travels from one medium to another medium, definitely wavelength will change. Due to changing in wavelength, speed also changes. Due to changing in speed, definitely path of the ray of light can be changes. Actually, this we are calling path of the ray of light. How it changes? It changes like this, as it travels from one medium to another medium. But remember this point, whenever light travels from one medium to another medium, definitely speed changes. Due to changing in speed, what will change? Wavelength also changes. But during refraction of the light, the physical quantity frequency of light remains same, because frequency is characteristic property of the source but not characteristic property of the medium. Look at me, what I am saying, during refraction of light, frequency and phase of the light, phase remains same. This is important. This frequency and phase that depends on characteristic property of the source but not characteristic property of the medium. I mean, when a ray of light travels from one medium to another medium, always frequency remains same and phase of the wave remains same. Look at me, these two physical quantity remain same. But what will change? When a ray of light travels from one medium to another medium, definitely wavelength changes. Due to changing in wavelength, speed also changes. Due to changing in speed, it changes in direction. So that refraction I can define in two ways. One way is the phenomenon of changing in speed of light when ray of light travels from one medium to another medium, or the phenomenon of bending of ray of light or phenomenon changing in path of light when ray of light travels from one medium to another medium. This phenomena we are calling refraction. Then see here, actually here some angles will define. Already I said that PA is nothing but incident ray, and AB is nothing but refracted ray, and N dash is perpendicular normal to point of incident. Look at me. Let us take here. This we are calling incident ray and this is normal. Angle between incident ray and normal, this we are calling angle of incident. Angle between refracted and normal, this we are calling angle of refraction. How it is? Angle between incident ray and normal is called as angle of incident. Angle between refracted and normal is called as angle of refraction. Then, to understand laws of refraction, we need one more term that we are calling refractive index. Look at me. Let us define one more physical quantity. That physical quantity is very important for refraction, that we are calling refractive index. Refractive index. Refractive index represented by eta or represented by n. So mu like this. This is n. Either you can represent by this quantity also. This significance also like this. Either you can represent by n or represent by mu, refractive index. Look at me. To understand concept of refractive index, let us take two medium separated by some bridge. Look at me. I can take this nothing but the line separating two mediums. I can take this is nothing but the line separating two mediums xy. I can take this is air medium. Then I can call this is nothing but say this is water medium. For my convenience, I am taking it is water. Right? Two mediums are there. We know that when a ray of light travels from one medium to another medium, definitely it changes the direction. How it is? Look at me. This is nothing but one ray of light incident at this point. Say I can call this nothing but PA ray of light incident at point A. How it is? Perpendicular line drawn at the point of incident we are calling normal. Are you following me? Then how the ray of light can be refracted? Ray of light can be refracted like this. In this way ray of light can be refracted. So can call this is nothing but PA is nothing but incident ray and AB is nothing but refracted ray. Are you following me? And I can call N dash is nothing but normal at the point of incident. See here. Let us take in air, speed of light can be represented by c value. In water, the speed of the light can be represented by v value. Because when ray of light travels from one medium to another medium, definitely speed of the light it changes. Question is, how to define refractive index? Refractive index is simply the ratio of speed of light into medium. Refractive index is the ratio of speed of light into medium. How it is? Refractive index can be represented by n. How it is? Ratio of speed of light into medium. Look at me. So, ratio of speed of light in air or speed of light in water, or ratio of speed of light in water to speed of light in air, that we are calling refractive index. Look at me. This air has refractive index that is represented by n1. Air has refractive index represented by n1, and water has refractive index n2. Water has refractive index n2. Then how to give? When ray of light travels from one medium to another medium, say ray of light travels from rarer medium to denser. I will come to the point. What is mean by rarer? What is mean by denser? Look at me. For my convenience, I am calling this air is nothing but rarer medium, and this water I can call denser medium. Water I can call denser medium. How it is? A ray of light travels from air to water, or ray of light travels from rarer medium to denser medium. Then how to give? Refractive index of second medium with respect to first medium. How to give this? Refractive index of second medium with respect to first medium can be represented by n2 divided by n1. How to write this value again? Refractive index, how to read this? Refractive index of second medium with respect to first medium. In what I can define? Refractive index of second medium with respect to first medium is equal to C by V. C by V. This is the how to read this. Either you can represent by this symbol or this symbol. Refractive index of second medium with respect to first medium. Simply I can call refractive index. But look at me. Now I can take one more way. Look at me. Simply I can define refractive index in what way? Refractive index is nothing but ratio of speed of light into medium. Ratio of speed of light into medium. Look at here. Now I can take refractive index of first medium with respect to second medium. First medium with respect to second medium. How to give? First medium with respect to second medium is equal to what value? N1 divided by N2. That is what value? C by V. C divided by V. Refractive index of first medium with respect to second medium. But this refractive index we can define in terms of wavelength also. How to define in terms of wavelength? Look at me. What is general formula for refractive index? See here. It has refractive index N1, refractive index N2. For air medium N1, for denser medium is nothing but N2. Look at here. How to give? We know that refractive index either represented by mu or represented by n. Refractive index is equal to simply ratio of speed of light into medium. Remember this point. Either you can take refractive index of second medium with respect to first medium, or first medium with respect to second medium. Right thing? Then we know that in air how much speed of the light? Speed of the light can be represented by F into lambda. Right? In water, what is speed of light? Speed of light can be represented by what value? It is F into lambda dash. Because already I said that when ray of light travels from one medium to another medium, always frequency remains same. But what will change? Wavelength will change. Here in air, lambda is nothing but wavelength. In water, wavelength is nothing but lambda dash. So that. Put these values here. How to write this refractive index then? N is equal to C. C is equal to how much? F into lambda. V is equal to how much? F into lambda dash. F get cancelled. Then what is refractive index? Refractive index is equal to how much? Lambda divided by lambda dash. Then what I can define? I can define refractive index in this way also. One way is ratio of speed of light into medium, that we are calling refractive index, or ratio of wavelength of light into medium, that also we are calling refractive index. But this refractive index can define in two ways. One is absolute refractive index, second one is relative refractive index. Let us define what is meant by absolute refractive index, what is meant by relative refractive index, that we'll see. Look at me. Let us take, after this we'll see what is meant by relative refractive index and absolute refractive index. Two terms will define in detail. See here. Look at me here. One is absolute refractive index. Absolute refractive index, first term. Later we'll define relative refractive index. Now let us consider two medium separated by some surface. Look at me. This is the line separating two medium, say xy is the line separating two medium. One medium I can call air, say for this refractive index is N1, and let us take one more medium I can take, let us take this medium is glass for example, not water I will take the glass. This has refractive index into, right around this. Now let us take a ray of light incident on the surface xy. Ray of light incident, let us take, I can take PQ is nothing but ray of light incident at point Q, right around this. Then perpendicular line drawn at the point of incident we are calling normal. This I can call normal. How the ray of light can refract it? Now ray of light can refract it like this. In this case the ray of light is refracted. Right around this, what we are calling angle between incident ray and normal. This we are calling angle of incident. Angle between refracted ray and normal, this we are calling angle of refraction. Following me? How it is? PQ is incident ray, QR is refracted ray, and we are calling N, Q, N dash is nothing but normal. Right around this. How to define refractive index? Absolute refractive index. See here. Initially I can define refractive index in what way? Refractive index is ratio of speed of light into medium. In air the speed of light can be represented by c. In glass the speed of light can be represented by v. Question is, what is meant by absolute refractive index? How to give? Refractive index of a second medium with respect to first medium. Refractive index of second medium with respect to first medium. Or how to write this value? Refractive index of second medium with respect to first medium is equal to how much? That is c divided by phi. Absolute refractive index means refractive index of second medium with respect to air or vacuum. I mean, if the second medium is glass, or second medium is water, or second medium is ether, second medium whatever it may be, but first medium must be air. First medium must be air or first medium must be vacuum. I mean, the refractive index of second medium with respect to air or vacuum is called as absolute refractive index. How to define absolute refractive index? Refractive index of second medium with respect to air or vacuum. For air or vacuum, refractive index is one value. For glass it may be 1.5, it may be 1.6 depending on nature of the glass. See here, if N1 is equal to 1, then what I will take? I will take N2 is equal to N. For example, this value may be 1.5, 1.2, whatever it may be. Then how to write absolute refractive index? So N2 can be replaced by N and N1 can be replaced by one value, so that you can represent by what value? C by V, or N is equal to how much? C divided by V. What it is? Absolute refractive index. How it is? Refractive index of second medium with respect to air or vacuum is called as absolute refractive index. Now, after this, let us define one more term that we are calling relative refractive index. Relative refractive index, RI. Relative refractive index. To understand this, now let us take two mediums. Say I will take water and glass. Water and glass. Look at. Again I will take, this is the two medium. Say this medium I can take water medium. It has refractive index n1. Water has not refractive index, n is equal to 1. n1 is equal to 1. It values around 1.33. And let us take, it is a glass medium. It is a glass medium. So for this refractive index is n2. Now I can take, this is surface, xy is the surface, right? Now we know that when ray applied incident at this point, let us consider one more ray applied. Say PQ is nothing but ray applied incident at point Q, and perpendicular and drawn at the point of incident we are calling normal. When ray applied incident at point Q, this ray applied must refract in this way. Again, this becomes angle of incident, this becomes angle of refraction. Right thing? Now, how to define refract? Generally, how to define refractive index? General formula. Refractive index is nothing but ratio of speed of light into medium. So let us consider, in this case, the speed of light I will take, it is V1 value, and in this case it is V2 value. So shall I take it is ratio of speed of light into medium. Say it is V1 by V2. Now, refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. How it is? That I can take n2 divided by n1 is equal to how much? V1 divided by V2. What is relative refractive index? Refractive index of second medium with respect to first medium, that we are calling relative refractive index. I mean, the first medium should not be air or vacuum. First medium should not be air or vacuum, and second medium whatever it may be, either it is glass, either water, it is ether, whatever it may be, second medium. I mean, refractive index of second medium with respect to first medium, that we are calling relative refractive index. For example, it is water, it is glass, or it is glass, it is water, it is ether, and this is nothing but glass, whatever medium it can take, or you can take water and this is diamond, whatever medium you can take. I mean, ratio of speed of light in two medium other than air or vacuum, that we are calling relative refractive index. Then after this, again you will see two medium, one we are calling rarer medium and second one we are calling denser medium, that we will see. See here. After this, let us define one more term, two more term, that we are calling rarer medium. Rarer medium. Rarer medium, and second one denser medium. Second one we are calling denser medium, right? Rarer medium means the medium which has lower refractive index. The medium which has lower refractive index, that we are calling rarer medium. I mean, for air and vacuum refractive index is 1, this medium I can call rarer medium. I mean, the medium which has lower refractive index medium is called as rarer medium. Is called as rarer. I mean, the medium which refractive index is lower, that we are calling rarer medium. For example, look at me. I will take two medium. Now I can take, this is air, right? And second one I can call water. For air refractive index is 1, for water refractive index is 1.33. Among these two medium, which is rarer medium? The medium which has lower refractive index called as rarer. Here air is called as rarer medium and water is called as denser medium. Denser medium means the medium which has higher refractive index. Medium which has higher refractive index, that I can call denser medium. For example, I can take. Now denser medium means I can take like this. So many examples I will take. For air, and let us take it is water. So you can take, this is glass, different medium I will take. For air, refractive index is 1 value. For water, refractive index is 1.33. For glass, refractive index is 1.5. Now remember, from this point, which is rarer medium, which is denser medium. That is important here. See here. If we compare air and water, which has more refractive index, water has more refractive index. So this is called as denser medium, and air is called as rarer medium. Rarer mean the medium which has low refractive index called as rarer medium, and the medium which has high refractive index called as denser medium. Remember this point. But if we compare, leave this. If we compare water and glass, which is denser medium, we know that medium which has high refractive index called as denser medium, glass is called as denser medium, and water is called as rarer medium. Right? Now, denser means simply any medium which has high refractive index called as denser medium, any medium which has low refractive index called as rarer medium. But question is, when ray of light travels from rarer medium to denser medium and denser medium to rarer medium, how refracted light can take place, that we'll see. See here. See here. Shall I remove this? Look at how to take this. Initially I can take ray of light travels from rarer medium to denser medium. First case, light travels from a rarer medium, rarer to denser medium. Rarer to denser medium. This we'll see. So simply you get the meaning of rarer medium and denser medium. What is meaning of this? Now I'll take two mediums. Shall I take one medium? I can take air. Its refractive index is N1. Let us take this medium is separated by one more medium. For my convenience, let us take, I will take second medium is nothing but water. Second medium is water. Its refractive index is N2. Right? What we know? Let us take the ray of light incident at point P or at point Q. Let us consider PQ is nothing but ray of light incident at point Q. Right? And perpendicular line drawn at point of incident is called as normal. This we are calling normal. What the normal here? I can take N, Q, N dash is nothing but normal. Look at me. When ray of light travels from rarer medium to denser medium, rarer medium to denser medium, ray of light is refracted towards normal. Towards normal mean this is normal. How the ray of light refracted? A ray of light can refracted like this. Like this. I mean, when ray of light travels from rarer medium to denser medium, from air to water, ray of light is refracted towards normal. In this case, this we are calling angle of incident and this we are calling angle of refraction. This second of angle of refraction. See here, when ray of light travels from rarer medium to denser medium, ray of light refracted towards normal and angle of incident always greater than angle of refraction. Angle of incident always greater than angle of refraction. One thing. And you are defining one more angle that we are calling angle of deviation. See here, how the incident ray, this incident ray, if I produce incident ray in this direction, are you following this? Then angle between refracted ray and incident ray produced, this we are calling angle of deviation. This I can call angle of deviation. See here, this total angle must be equal to this angle. Then generally from geometry how to write? I is equal to how much? I is equal to R plus D. What is the angle of deviation? What is our angle of refraction? I angle of incident. Then what is angle of deviation from this? Angle of deviation is equal to I minus R. I minus R. When it is, see here, when ray of light travels from air to water or ray of light travels from rarer to denser, what I can call? This I can call denser medium, this I can call rarer medium, because it has lower refractive index, it has higher refractive index. When ray of light travels from air to water or from rarer to denser, angle of incident always greater than angle of reflection, and angle of deviation can be given like this. This is the first case. Second case we will see. Ray of light travels from denser medium to rarer medium. Second case shall I see? Second case, how to say? Ray of light travels from denser to rarer medium. Denser to rarer medium. That will see. Denser to rarer medium. Are you following this? Now. Again I can take two medium, I can take, let us take this in line separating two medium, I can call it is XY. Say this I can call denser medium, say shall I take? I can take this is water, or I can take it is glass. Not only water you can take this is glass. Alright. This has refractive index N1. And let us take, I am taking water in this case. Water. So this has refractive index how much? N2. Refractive index of glass is 1.5. Refractive index of water is 1.33. So it is denser medium, it is a rarer medium. Are you following this? What I can call glass now? Glass you can call a denser medium. This I can call denser medium. And this water I can call rarer medium. Shall I call this water? It is a rarer medium. Writing this. Let us take a ray of light incident. How this is? Consider this is nothing but ray of light incident at point Q. I can call PQ is nothing but ray of light incident at point Q. Perpendicular line drawn at the point of incident we are calling normal. Read down on this. Now, when ray of light incident, how it get refracted? When ray of light travels from denser to rarer, ray of light refracted away from the normal. How it is away from the normal mean? Refracted ray must go like this. Refracted ray, deviated away from the normal. Right thing. Now, this we are calling angle of incident, and this we are calling angle of refraction. In this case, what happen? Angle of incident greater than angle of refraction, and in this case, angle of refraction always greater than angle of incident. Right thing. Now, we know that this is nothing but incident ray. Incident ray produced in backward direction, like this, forward direction. Then angle between refracted ray and incident ray produced, this we are calling angle of deviation. This I can call angle of deviation. Here what happens here? D is equal to I minus R. In this case how to take? D is equal to R minus I, reverse of that value. Right? When ray of light travels from rarer to denser, angle of deviation can be given like this. In case of ray of light travels from denser to rarer medium, ray of light can be taken like this. I mean, angle of deviation must be R minus I, just reverse of this. Now, what are laws of refraction? That we will see now. After this, let us take what are laws of refraction. After this, let us take laws of refraction. See here. Let us take from this laws of refraction. Laws of refraction. Are you following me? Now, again we will take the ray of light travels from one medium to another medium. See here. This is line separating two medium. I can call this line is nothing but xy. So this medium I can call air medium, or I can call denser, whatever it may be. I can take air, say refractive index is n1, and second medium I will take, let us take it is glass medium. So this refractive index is n2. Are you following this? Now, let us take ray of light incident at this point. At this point, consider this nothing but AB, nothing but incident ray. AB incident ray, incident at point B. What we know? Perpendicular line drawn at the point of incident, we are calling normal. We are calling normal, right? When ray of light travels from rarer medium to denser medium, ray of light refracted towards normal. So this I can call BC. BC nothing but refracted ray. Right thing this is. Angle between incident and normal is called as angle of incident. Angle between refracted and normal is called as angle of refraction. Now let us see what is first law of refraction. First law. First law of refraction. First law says that the incident ray, refracted ray, and a normal drawn at point of incident. What is normal? Normal is nothing but n, b, n dash. How it is? The incident ray, refracted ray, and normal drawn at point of incident all are lying in same plane. This is first law of refraction. How this is? Incident ray, refracted ray, and normal drawn at point of incident all are lying in same plane. This is first law of refraction. Shall I write? The incident ray, refracted ray, and normal drawn at point of incident, all are lying in same plane. Point of incident all are lying in same plane. Same plane. It is first law of refraction. First law of refraction. Look at me. Now let us take what is second law of refraction. Second law of refraction. Second law of refraction, also called as Snell's law of refraction. The second law or Snell's law of refraction says that ratio of sine of angle of incident to sine of angle of refraction for a given pair of media is constant. How it is? The ratio of sine of angle of incident, ratio of sine of angle of incident ratio of sine of angle of incident to sine of angle of refraction. Sine of angle of refraction is constant for given pair of media. For given pair of media. How it is? The ratio of sine of angle of incident, to sine of angle of refraction is constant, and this constant is called as Snell's law of refraction. This constant is called as refractive index of the medium, and this law is called as the Snell's law of refraction. How this is? The ratio of sine of angle of incident to sine of angle of refraction is constant. This law is called as Snell's law of refraction, and this constant is called as refractive index of medium. See here, this law how to take? Refractive index of second medium with respect to first medium. Refractive index of second medium with respect to first medium. Or else how to write? I can take sine I divided by sine R. Sine I divided by sine R is equal to what way? Refractive index of second medium with respect to the first medium. Or else, again I can modify this. Again, how to modify? N1 sine I is equal to N2 sine R. This law I can call as Snell's law of refraction. Snell's law of refraction. Snell's law of refraction. Are you following this? Ratio of sine of angle of incident to sine of angle of refraction is constant for a given pair of medium. But the second law of refraction only valid if ray of light incident at some angle. If the case the ray of light incident along normal like this, along normal mean like this. How it is? Shall I take separately? Now I can take this is two medium, say I can take it is air. What about this? This is water. Remember this. When the ray of light incident along normal mean in this direction. When ray of light incident perpendicular, it never refracted. It never refracted. How it goes? Either it can go from down to top or from top to down. When ray of light incident perpendicular to surface, ray of light never refracted. So, in this case there is no angle of incident. See here, in this case there is no angle of incident, and in this case there is no angle of refraction. Right on this? There is no angle of incident. I is equal to 0, R is equal to 0, then N is equal to not 0. Refractive index is not 0 for any medium. So that this Snell's law of refraction not valid when a ray of light incident perpendicular to surface or along the normal. If the ray of light incident perpendicular to surface or along the normal, the Snell's law of refraction does not valid. So these are laws of refraction concerned to first law and second law. The remaining concept we will see in the next session. Thank you guys.